There are a few different types of quadratics, and when it comes to factoring them, there's a different method to use for each type of quadratic. Rather than showing you all of the methods, your textbook suggests you just look at the question and substitute in all the possible answers that they've given you and see which set of answers works. I think that's a great idea for checking your final answer, but it doesn't show you how to actually factor. So in this video I'd like to show you how to factor the most common types of quadratic functions. The one you'll come across most often would be a type 1 trinomial. Trinomial is one that has 3 terms in it and would probably look something like this: x squared plus 5x plus 4. When you want to factor a trinomial like that, we're going to be looking for factors of the last term that can add up to your middle term. So what we do is ask ourselves what two numbers can multiply together to make 4, but if I were to add them together to make 5. If you can come up with those numbers, you're done your factoring. All that's left to do is put them in your factored brackets. I'll give you an example. X squared plus 6x plus 8. It might take you a little bit longer to think of the factors than it does for me, so you might want to pause the video while you think of all the possible factors. In my head, I'm wondering, what factors are there of 8, or numbers that multiply to make 8? There are 1 and 8, or 2 and 4. Now I'm trying to think if one of those options could also be added together to make 6. And I see that a 2 and a 4 would work. Once I've picked my factors, all I need to do is set up my factoring brackets, take my variable, which was x, and my first term was squared, so I put an x in each bracket, and then I put my two terms, a positive 2 and a positive 4. They multiply together to make positive 8 and add together to make positive 6. The next example is a little bit different because I need two numbers that multiply together to make negative 12, but that add together to make positive 1. So I know my numbers are going to have different signs if they'll multiply together to make a negative number. I'm thinking of all my factors of 12. And again, if this is going to take you a little while, just hit pause. I noticed that 3 and 4, if they had opposite signs, could multiply together to make 12, but add together to make 1. If the 4 was positive and the 3 was negative, they would add together to make positive 1 and multiply to make negative 12. In the next example, both terms are negative. Not only do I want it to add to a negative number, I want it to multiply to 1 as well. So the factors of 8 are 1 and 8 or 2 and 4. And I want it to add to negative 2, so I'm going to use x minus 4 and x plus 2. If you ever want to check your answer, all you'd have to do is FOIL it out and make sure that the answer you get is the same question you started with. So you can always check your answer. Finally, the last one, numbers need to multiply to positive 6 and add to negative 7. In this case, I'm going to use 1 times 6. If both numbers were negative, then negative 1 times negative 6 multiply together to make positive 6, and negative 1 plus negative 6 add together to make negative 7. These are the types of trinomials you'll see most often and what you'll spend most of your time on. There are another set of trinomials which are more difficult, and we call them type 2 trinomials. These are the ones that have coefficients in front of your first term. So it might be 5x squared, or it could be 2x squared, and so on. In that case, we can't just look for factors of the last term that add to the middle term. Instead, I'm going to show you a grid system where we'll list all the factors of the first term and then the factors of the last term, and in order to determine which factors to use, we'll make sure the cross products add up to our middle term. Let me show you. So that example of 5x squared plus 13x plus 8, what I need to do is draw myself a little grid. This can just be done in the corner of your page. It doesn't take up very much room. On the column to the left, I want you to choose factors of your first term. Usually your first term is a smaller number, so it doesn't have a lot of factors to choose from. In this case, it's 5x squared. 5 doesn't have that many factors. Probably 1 times 5. So 1x and 5x are my factors of my first term. In the second column, write factors of your last term. My last term is positive 8. I'm not going to assign my factors positive or negative signs just yet, but I know it could be 1 times 8 or 2 times 4. I'm going to choose the 1 and the 8, and I'll put the 1 here and the 8 down here. If you chose the wrong answer, that's okay. You can just scribble it out and start again. That's what's nice about using this method. It doesn't take up that much room. Now I haven't assigned signs to my factors of my last term just yet. What I want to do is check the cross products. Multiply diagonally downward 1x times 8 to make 8x, and then up 5x times 1 to make 5x. My goal with the cross products is for the cross products to add together to make my middle term. In this case they do, 8x and 5x. It would work if both of those numbers were positive. So I had positive 5x and positive 8x. If you can get your middle term, then you know you've chosen the right factors. If you can't get your middle term by moving the numbers around in any order, you need to start again. You've probably chosen the wrong factors. Now your factors are just your rows. 1x plus 1 is one factor, 5x plus 8 is the other. So x plus 1 and 5x plus 8. One other rule to keep in mind is that any given row on your factoring grid cannot have a greatest common factor other than 1. So for example, I couldn't have a 2 and a 4 in the same row, since that greatest common factor would be 2. So that would tell me that I've made a mistake. Let's try another one. Again, if you need more time to do these, just hit pause, do it on your own, and then see if you got the right answer. In the first column, you put factors of the first term. 7x squared. The only factors I can think of would be 1x squared or just x squared and 7x. Pardon me. 1x and 7x. There we go. In the second column, put factors of your last term. Luckily it's a 2 here, so the only factors I have are 1 and 2. The question is, what order do they go in? I'm going to put them in the wrong order just to show you how easy it is to correct yourself. Now what I want to do is do cross products to see if I can make these numbers add up to my middle term. If I had the numbers in this order, I would get 14x this way and 1x that way. I'm trying to make my numbers add up to 9x, and in no way can I make a 14 and a 1, even with positive and negative signs, add up to 9. So I know I've made a mistake. I just scribble it out and start again. My x and my 7x were okay, but in the second column I'm going to just change the order of my 1 and 2. So that here I've got 7x when I go diagonally, and here I've got 2x. That adds to 9x. So my factors, remember, are the rows. X plus 1 and 7x plus 2. There are older methods of factoring trinomials like this, and maybe that's what you're comfortable using. They do take up more room and time, and like I said, they're outdated, but if you have another method for solving type 2 trinomials, feel free to use it. When you fill in the factors of your first term, it really doesn't matter which order you put them in. It's the second row where we fill in factors of the last term that we're going to fiddle around with a little bit. I can see right now I'm trying to make these add up to 7x, so I'm going to put it in this order, 1 and 2 for my factors of my last term. So when I do a cross products, I get 6x and 1x, which does add up to 7x. Both of those numbers were positive. 3x plus 1, x plus 2. Now again, if you were to come across these questions in your book, they suggest just taking all the possible answers that you're given in your multiple choice question and putting them all into the question to see which one works. That method is fine. It will work on multiple choice exams, but like I said before, it doesn't really teach you how to factor. There's one other type of common factoring that you might see, and it's a difference of squares factoring. It's when you have one square number subtracted from another square number. For example, 9x squared minus 36. 9 is square, x squared is a square number, and 36 is a square number. In situations like this, we just have to determine what the square root of each of the factors are. Then we'll set them up in our factoring symbols and give one a plus sign and one a minus sign. For example, that 9x squared. I know the square root of 9x is 3x. So the square root of 9x squared is 3x. Or in other words, the square root of 9 is 3 and the square root of x squared is x. I put that in the first spot of each of my factoring symbols. Then I do the square root of 36. I know the square root of 36 is 6. I put that in each of my factoring brackets as well. Now, it doesn't matter which order, but give one of your factors a plus sign and one of your factors a negative sign. If you were to check your answer when you multiply this out, you'll see that your middle terms cancel each other out, and that's why we're left with two terms. One final example, 4x squared minus 25. The square root of 4x squared is 2x. It goes in the first spot of each factoring symbol. And the square root of 25 is 5. It goes in the last spot of each bracket. Give one a plus sign and one a minus sign, in any order. As long as one's positive, one's negative, it doesn't matter which one comes first. And you're done factoring.